Bluetooth was named after Harald Bluetooth Gurmson, a Viking king known for uniting Scandinavia in the 10th century. Fittingly, Bluetooth technology unites devices. It was developed in the 1990s by Ericsson, a Swedish company, with the goal of replacing tangled cables. By the early 2000s, it became a standard feature in consumer electronics, paving the way for wireless keyboards, headphones, and even cars to sync up effortlessly. At its core, Bluetooth operates using radio waves. These are part of the electromagnetic spectrum, like the waves used in Wi-Fi and FM radio. Specifically, Bluetooth transmits data within the 2.4 GHz frequency range, a universally accepted band for short-range communication. This allows devices to talk to each other over short distances, typically up to 10 meters, though newer versions can extend even further. But here's the clever part. Bluetooth doesn't just shout messages into the air for anyone to pick up. It uses a technique called frequency hopping spread spectrum to keep the conversation secure and interference-free. Essentially, it rapidly switches between different frequencies within the 2.4 GHz range, hopping around 1,600 times per second. This makes it incredibly hard for unwanted listeners or other devices using the same band to eavesdrop or cause interference. Ever noticed how your Bluetooth speaker works differently from your wireless keyboard? That's because of Bluetooth profiles. These are predefined sets of rules that determine how devices interact. For example, the Advanced Audio Distribution Profile is what makes streaming music possible, while the Human Interface Device Profile, HID, governs keyboards and mice. Each profile is tailored to specific functions, ensuring smooth communication between devices. Before two Bluetooth devices can communicate, they need to pair, a process that might feel like an awkward first date. During pairing, the devices exchange information to establish a secure connection. This involves a process called device discovery, where one device broadcasts a signal and the other responds. Once they find each other, they generate a unique key, often secured with encryption, to keep the connection private. Think of this as a digital handshake. Once the devices agree on the rules of engagement, they establish a bond. After pairing, future connections are almost instant because the devices remember each other, like old friends picking up where they left off. Bluetooth technology has evolved significantly since its debut. Early versions were groundbreaking but limited in range and data transfer speeds. Modern iterations, like Bluetooth 5.0 and beyond, offer faster speeds, longer ranges, and greater energy efficiency. This is particularly crucial for devices like fitness trackers and smartwatches, where battery life is a top priority. The advancements also include features like broadcasting to multiple devices simultaneously and improved stability in crowded environments. One of Bluetooth's most transformative upgrades was the introduction of Bluetooth Low Energy, BLE, in 2010. BLE is designed for devices that don't need to exchange large amounts of data. Think heart rate monitors, smart locks, or IoT gadgets. Unlike traditional Bluetooth, BLE prioritizes minimal power consumption, making it a game-changer for battery-powered devices. It achieves this by sending smaller bursts of data less frequently, conserving energy while staying connected. You might associate Bluetooth with personal gadgets, but it's also stepping into the world of smart homes and industrial applications. Enter Bluetooth Mesh, a feature that allows multiple devices to form a network, much like a spider web. Each device acts as a node, passing messages along until they reach their destination. This enables applications like smart lighting systems, where you can control an entire building's lights with a single command. With all these devices chatting wirelessly, security is a valid concern. Bluetooth addresses this with several layers of protection. Pairing often involves encryption, ensuring that data exchanged between devices remains private. Additionally, Newer versions of Bluetooth have adopted more sophisticated authentication protocols, making it increasingly difficult for hackers to intercept communications. That said, it's always wise to disconnect from unfamiliar devices and update your gadgets to the latest firmware. While Bluetooth is a marvel of modern engineering, it's not without its quirks. Who hasn't experienced the frustration of a failed connection or a sudden drop in audio quality? These hiccups are often due to interference, outdated software, or low battery levels. Luckily, most issues can be resolved with simple fixes, like restarting devices, updating firmware, or ensuring they're within range. The future of Bluetooth is as exciting as its past. With the rise of wearable tech, smart cities, and the Internet of Things, IoT, Bluetooth will play a crucial role in connecting the dots. Emerging features like precise location tracking and ultra-wideband support promise to expand its capabilities even further. Imagine your smartwatch not just tracking your steps, but also guiding you through a crowded airport to your gate. That's the power of Bluetooth 5.2 and beyond. So, how does Bluetooth work? It's a sophisticated blend of radio waves, clever coding, and ever-evolving technology. From the initial handshake during pairing to the secure and efficient communication that follows, Bluetooth has revolutionized the way we interact with our devices. It's not just a convenience, it's a cornerstone of modern connectivity. The next time your earbuds sync effortlessly or your smartwatch buzzes with a notification, take a moment to appreciate the Viking-inspired magic that makes it all possible. Bluetooth is everywhere, and it's only getting better. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.